As we discussed previously in earlier lessons, in traditional data centers, there were normally two different networks. There was the data center local area network, and then there was a very specialized storage area network, which granted servers access to pooled storage in their environment. In the technology field, a lot of times when new technologies come out, they allow us to do things that we haven't been able to do in the past. And that's exactly what happened with 10 gigabit Ethernet and the ability to provide lossless fabric on an Ethernet switch. We were able to develop a protocol called Fiber Channel over Ethernet, which allows us to basically map fiber channel frames over Ethernet. And because we can provide a lossless fabric, it allows us to transport that mission critical data between servers and storage area networks. The benefits of this protocol is that we used to have cables for Ethernet networks and cables for SANs, but by combining both of those over a single cable, we can have fewer cables in the data center, which means less complexity, fewer cables, better airflow, smaller number of adapters needed per server, and overall less power. Above and beyond that, this Fiber Channel over Ethernet protocol interoperates with existing SANs and can integrate into your current management platforms. FCOE is really made up of two different protocols. There's a FIP protocol, or the FCOE initialization protocol, and that's mainly used to discover different fiber channel entities and allow Fiber Channel over Ethernet to log into the fabric. And then there's the FCOE protocol itself. And this is really the data plane protocol, and it's used to carry most of the fiber channel frames and all of the SCSI traffic. There are a number of steps that take place as the Fiber Channel over Ethernet devices attach to the network. The first one is that we look for the specific VLANs on the FCOE network that are being used for Fiber Channel over Ethernet. The second one is, once we've found that VLAN, we need to find our fiber channel forwarders so that we can log into the fabric. And finally, just like Fiber Channel, we log into the fabric and we establish a virtual link between the host and the fiber channel forwarder. This allows us to move from the architectures of today with a separate LAN and SAN environment into a consolidated environment with less complexity, where we can reduce the number of adapters that we have in servers, reduce the number of switches that we have in racks, and reduce the number of management overhead that we have in our network as a whole. This technology is very similar to what we've seen in the voice network and the data network, where those two have combined as one and provided many benefits to the industry. FCOE port types are very similar to what we've already discussed in the fiber channel network. As a matter of fact, everything's pretty much the same with FCOE as it is with fiber channel, besides the fact that our transport is now the Ethernet network instead of the fiber channel network. So if you take a look at our port types, we still use E port types to connect one switch to another switch. We put a V in front of it to say it's a virtualized Ethernet type, because we actually create virtualized instances of all these different port types that we use in FCOE. So for instance, we have a VF port type, or a virtualized fabric port type, that end nodes connect to, or even NPV ports connect to, as you can see in our virtualized N ports or in our virtualized NP ports or NPV ports. Here is a list of the different ports that are used in FCOE. As you'll see, they're very similar to what we use in the fiber channel network. They just have a V in front of them because they're virtual.